So in this question, we've been given an integral and we've been given a substitution to make in order to show that this integral is equal to this expression over here. Now, this may seem quite tricky at first, but if you slow it down, do it step by step, it will make a lot more sense and it will become a lot easier to do. So let's first start by just evaluating the differential operator that we're going to change. So we're using x equals a sine squared theta. So dx d theta is equal to, so power comes to the front, take one from the power times the differential of the inside. So this is basically equal to a times sine theta all squared. So power comes to the front, minus 1 from the power times the differential of the inside is cos. So this becomes 2a sine theta cos theta, which is equal to, so 2 sine theta cos theta is sine 2 theta. So this is equal to a sine 2 theta. So now what we can do is bring the theta to this side. So dx is equal to sine 2 theta, sorry, a sine 2 theta d theta. So wherever dx appears in this integral, we replace it with a sine 2 theta d theta. Now what we can do is rearrange these two expressions so that we can plug in our expression for theta instead of x. So if we take x to the power of a half, this is equal to a sine 2 theta to the power of a half. So that's equal to root a times sine theta. And then the square root of a minus x, so square root a minus x is equal to the square root of a minus a sine squared theta, which is equal to the square root of a, okay, I'll write like this, so square root of 1 minus sine squared theta all times root a, which is equal to the square root of cos squared theta using trig identities, and this is equal to root a times cos theta. Okay, now what we can do is plug this expression and this expression into here, and then we'll get a simpler expression in terms of theta. So before we do that, we'll do one last step, and then that is going to be changing the limits. So x equals a sine squared theta. So if x equals a, so we have a is equal to a sine squared theta. So sine squared theta is equal to 1. So sine theta equals 1 and theta equals pi over 2. Since it can't be negative because that will be a backwards integral. And then for x equals 0, theta will just equal 0. So yeah, I'll write that down here. So this is for x equals a, theta equals 0, and then for x equals 0, theta equals 0. So those are the limits that are going to be changed. So now let's rewrite this. So this is going to be equal to the integral between pi over 2 and 0 of x to the power of half, which is root a sine theta, times a minus x square rooted, which is root a cos theta, times dx, which is equal to, where is it, a sine 2 theta d theta. So times a sine 2 theta d theta. Now we just expand and simplify. So this is equal to pi over 2 to 0 of the integral. So root a times root a is a times a is a squared. Sine theta times cos theta is sine theta cos theta. And so yeah, I'll write that out first. Sine theta cos theta times sine 2 theta. And now this again, we can use double angle formula. So 2 sine theta cos theta is equal to sine 2 theta. So if we have sine theta cos theta, this is equal to half of sine 2 theta, because there's no 2 on this side. So we can write this as equal to pi over 2, 0 of half sine 2 theta times sine 2 theta d theta. And now the final step is just to bring half a squared the final step is to bring this constant outside of the integral. So this is equal to half a squared pi over 2 to 0 of the integral of sine 2 theta times sine 2 theta is sine squared 2 theta d theta, and that's exactly what the question wanted us to get at the start. Now the next part of the question wants us to evaluate the integral and show it's equal to k pi a squared, where k is a constant. So since we've already proven that the integral is equal to this expression in terms of theta, we can just use that because it's a much simpler integral than the one above. So first we need to change this using the double angle formula for cos. So if we recall, cos squared theta minus sine squared theta is equal to cos 2 theta. So we know that cos squared theta is equal to 1 minus sine squared. So 1 minus 2 sine squared theta is equal to cos 2 theta. So rearranging for sine squared theta as the subject, we get 1 minus cos 2 theta over 2 is equal to sine squared theta. Now since we've got sine squared 2 theta, this is going to be cos of 4 theta inside the cos. So let's rewrite the integral as equal to a squared over 2 times the integral from pi over 2 to 0 of 1 minus cos 4 theta over 2 d theta. So this is equal to a squared over 2 pi over 2 to 0 of, so 1, so the 2 is a constant, so it won't make a difference. So 1 integrates to theta, and then cos, so it's minus cos 4 theta. So cos integrates to sine, but since there's a 4 there, we have to do the reverse chain rule and divide by 4. So it's theta minus 1/4 sine 4 theta all over 2. Now I'm going to bring this fraction outside and then evaluate the integral of the inside. So this is equal to a squared over 4 of, okay, so this is going to be pi over 2 minus 1/4 times sine, now 4, so this would be 4 theta, so 4 times pi over 2 is 2 pi, so sine 2 pi, and then I'm going to do this minus, and then so with 0, and then sine 0 is just 0, so 0 minus 0, okay? Now we can just expand, so this doesn't do anything, and sine 2 pi is also equal to 0, so this whole term here becomes 0, so what we're really left with is just a squared over 4 times pi over 2, which is equal to pi a squared over 8. And we can rewrite this again as 1/8 pi a squared. Now at the beginning of the question it said it was equal to k pi a squared, and we've got 1/8 pi a squared, which means that k is equal to 1/8.